NASA space flight.
Like when the shuttle booster is being tested.
Nice. So, what's going on? I mean, we see a booster out there. It seems to be laying on the ground sidewards. What are we expecting today, y'all?
Yeah. So, if you are all familiar with those things that we sometimes refer to as static fires, when something's vertical on a pad and you light engines and you fire them off for a few seconds and then shut them down and just to make sure everything's going. I mean, I think there's a rocket or a couple out there that do that, right? Yeah, yeah. This is sorry, joking aside, this is the exact same thing as what we see at Starbase with starships and what we see at the launch sites when Falcon 9s do their static fires, except this is how you static fire a solid rocket booster. Um, you generally lay them down on their sides like this. They're just easier to handle that way with the segments and the weight and the mass that goes into this. So this is a solid rocket booster for the SLS program. It is fully fueled, just like the ones on Artemis 1 are right now. And what they're going to do is fire it. And it is a full duration hold down static fire. So this booster will fire for just over 2 minutes, producing upwards of 3.3, 3.5 million pounds of thrust as it really peaks out there. During its thrust profile. And the reason for this is they need to continue to test them so that they understand that quality control through the regular production process is being maintained. So this booster was built the exact same way that the SLS solid rocket boosters are. So they're getting good data on the process of their quality control. but tests like these are actually another really important way that they, especially when you don't recover the solid rockets, that you still maintain that level of safety understanding of what the field joints are doing. Because as a lot of us remember, and for those of you who don't, it was a failure of the O-ring seal, and the temperatures on the day that led to the loss of the Challenger 7 crew members on January 20th, 1986. And since then, we have not had burn throughs of any of the joints on the solid rocket boosters. And they have taken great care to make sure of that. And one of the reasons for these tests is exactly that, maintaining that level of safety, which actually does come to a question that we have here in chat, which was during one of the previous test firings here, they actually cooled the booster down. Did they do that today? Which is an excellent question. And the answer is no, they did not do that today, but you are correct. They did it with the previous static firing. So today is what is known as Flight Support Booster 2. And it's basically, okay, this is the design that was certified to fly, and we're just testing our quality control processes and testing new little things that we're going to upgrade along the way with new technology. Right. But flight support, so this one today, Flight Support Booster 2, is being tested just at whatever temperature it's at right now out in the Utah sun. That's what it's being tested at. But Flight Support Booster 1, a couple of years ago, was actually tested at 15.5 degrees Celsius or 60 degrees Fahrenheit. So they cooled it down so that they could see how those joints were reacting in the colder temperatures. So they do have the ability to modulate the temperature of the booster and the propellant to test within its operational temperature range what it's actually going to perform at. So great question there.
Excellent. Hey, real quick, let me grab a couple of these super chats that
Yeah.
are coming in. Musical Wolf says, after the test, does the booster weigh less than before the test? I think yes. The booster weighs a lot less after the test.
I can
Yes.
actually give a little bit of an answer to that, by the
Oh
way,
yeah.
because people wonder what's inside this booster, what the solid propellant look like. It's amazing. We've seen very few photographs because it's all proprietary stuff, but it's like a cake mix. They literally pour in what looks like a cement cake mix into these boosters with a mandrel down the middle of it to provide the actual thrust dynamics of what the shape will look like once it's set. But it literally is like throwing cake mix into a big tin. And that's how they make the segments. And then they bond them and then they join them. And that's when you get the solid booster from.
Yeah, they let it like cure. It's literally something you pour
Yeah.
in and then it like cures in a specific grain pattern and shape and that sort of thing. That's really cool. It's like cake mix. I never thought of it that way.
And that
Let's see.
and that bore that you just said is how you control the thrust of a solid rocket and how
Ah,
you
Yep.
yes.
throttle it during flight. Yes.
The amount of surface area that's currently sort of reacting, I guess is the right way to say it, can control how much thrust you get over time, and you can change the burned surface area over time to change the amount of thrust you get. Roughly. Um, let's see here. Here's another one from Musical Wolves, and y'all, just so you know, we're about 12 minutes away from the expected T0 of this
Woo.
test. Should be at 10 minutes after the hour out there in Promontory, Utah. Musical Wolves asked, what happens to the solid propellant once it's burned? Does it stay in the booster or does it come out? Like, is it just a big empty tube at the end of the test?
Yes.
Yeah.
Yes, it is. It is a big empty tube.
Ah,
What happens to it? It's the flame you see coming out the back end. That's
yeah.
exactly what happens to it. It is burned to completion.
Excellent. Excellent. Yeah, it creates thrust and it pushes rockets into space, which is excellent. But very good question there, Musical Wolves.
By
Let's
the
see
way, I'm going to
here.
quickly interject. I'm going to put a link into chat to show what the mix looks like. And trust me, it looks like cake mix to me.
Nice. That's in the YouTube chat, right?
Yes. Oh, I can actually
Cool.
send it to the control panel if you want. Oh, sorry, I should have thought
Excellent.
about that.
It looks like a it
Oh,
looks like a
yeah, there it is, Doss. Yeah,
it
yeah,
looks like a
yeah.
toilet seat.
A
What
little
the
bit.
heck?
That's how to mix it. It's a mixing bowl.
I'm like making sure that what you're sending me is safe to show on the screen,
It
Chris.
is.
Ah!
It
This
is.
is this is like L2 content, I guess.
But no, I've made it into an article so you
No?
can use
Oh,
it.
good.
Oh. So look here, this is what Chris was showing me, the link that he put in the chat. That is actually some of the propellant when it's in sort of quasi liquid form, I guess cake batter form before it's cured out inside the booster, right?
But don't lick that spoon.
It's a forbidden snack, Jack says.
Yes.
Nice.
It's a forbidden snack. I like it.
Excellent. Thank you for that, Chris. I'd never seen that before. That's really cool. Let's see here. Space Shuttle Discovery says, "Am best shuttle." Sorry. Oh, I shouldn't have read that one. Sorry, Space Shuttle
Yep.
Discovery. Goodbye. Thank you for the support.
Yeah.
Aravel says, "What are everyone's favorite sandwiches?" Mine is SLS. Is it like a sandwich lettuce sandwich or something? I don't know. Aravel,
Yeah, that's
thank you. Yehuda Burger, is this the second test for this type of booster? Have they fired one like this before?
great question. So while this is Flight Support Booster 2, meaning it's the second one of the flight supports, same processes, completely used for SLS, not the first time. There were also several qualification and demonstration motor firings of the 5-segment booster prior to the flight support test. So it basically goes, we're designing it, demonstration firing. Now we're qualifying it for flight, qualification firings. Now we're just maintaining flight status, flight support booster. That's sort of the 3
Gotcha.
categories of firings that they have for these things.
And I think, like Jack was saying earlier, this is a qualification firing, or like, what was it about
No.
the igniters?
Yeah, so no, it's technically a flight support booster, but what they're testing is already qualified new motor ignition systems and new ablative nozzle lining. So basically, that second one, new ablative nozzle lining, is just how to keep the nozzle from melting. But basically, those 2 things have already been qualified for flight. We're just testing them now in flight configuration, basically, to make sure.
Gotcha.
And then it's the new thrust vector controls, the actual controls that will steer that nozzle at the end is the qualification part, at least how it was described to me. But Jack is actually saying that this is slightly different than what came out to the media, but they had a subject matter expert briefing them there on the ground that said the igniter is also being qualified today too. So
Gotcha.
slight difference there, but we'll go with what the SME says. So qualifying the new motor igniter and the thrust vector control systems.
Gotcha. So it's like they made a couple of them, and then they're testing this igniter to make sure that that stack they made, the group or lot that they made, is good to go. And if this one works fine, then they can say those other 2 we made out of the same batch should also be fine. If I've sort of summarized that poorly.
I think you got it correctly. And yeah, Jack
Yeah.
is confirming that the subject matter expert was saying that this qualifies the A3 igniter, basically.
Gotcha.
Yeah.
All right. I think 8 is that Artemis 3. That's
Ah,
Artemis
I
3.
think that no,
Yeah.
but I like that.
I don't know. Does it is that Artemis 3's igniter?
Yeah,
A3's
yeah.
igniter? Like Alpha 3? I'm not sure.
Also,
Um,
I've got a quick point to make on how they check the booster after these tests to make sure everything has gone as planned to qualify these elements, and that is you'll see a CO2 extinguisher on a robot arm move in just after it flames out, just after the thrust down, and that literally puts out as much fire as possible so that when they've completed the test, they can get the components at the point the booster shut down without any subsequent fires that may occur because it's still obviously on the ground. When they were coming back after being expended in space, they'd come back down and put themselves out anyway. So that's how they do it on the ground with a CO2 extinguisher.
I think I've seen that before. It's like a fire extinguisher on a stick or something, isn't
Yep.
it?
Well, a
Yeah.
robot arm.
A robot arm.
Yeah.
Stick, robot arm, what's the difference? All right. Let me see if I can't grab a couple super all right, timeout. We're trying to get an accurate T0 here so we know when this test is supposed to happen. So there's a little bit of confusion on exactly when the test is going to go. It was supposed to be 1 o'clock, and then it was going to be 1:10, and then it was going to be 1 something, and now it's 1 question mark. So give us just a second while we try
Yeah.
to figure out the exact timing here.
And actually, yeah, I can keep running some questions and support if we want to.
Yeah,
Yeah.
let's do that.
Yeah.
Let's do that, Chris.
Yeah, well, right off the bat, Chris K, thank you so much for the $100 super chat. Just
Chris
saying,
K again.
yeah, Chris K again. Man, I also got to say, I can't wait to meet you in a week, Chris K. That's going to be fun. Really can't wait to meet you. But yeah, thank you so much for that support. Saying for the Jack Car and Donut Fund and Coffee Fund. So Jack, you've got some gas, coffee, and donut fund money. There we go. Coming, but seriously, Chris, thank you, very much appreciated. Bree with the €5. No, nothing, just €5 of support. Thank you so much. Jim Cavett saying thanks, Jack. fire this. Yes, Jack.
Hey,
Yes,
Jack!
I heard that. Yes, hello.
We heard Jack for a second.